When toxicologists test a chemical's safety, they typically use high doses to find health problems. But that approach has missed the potential dangers of some substances that can be hazardous in tiny amounts. They're known as endocrine disruptors because they mimic or block hormones. Some, like bisphenol A and phthalates, are common ingredients in plastics and other consumer items. Recently, the government's National Institute of Environmental Health Sciences published a paper challenging regulators to change chemical safety tests to reflect this emerging scientific understanding about low doses. Dr. J. Peterson Myers is the lead author.
Our regulatory safety net, the FDA or the EPA, they all depend upon a core assumption that when they test at high doses, those tests will reveal what's happening at low doses. The problem is that when you're dealing with contaminants that behave like hormones, it doesn't work that way. They do one thing at high doses and potentially something completely different at low doses. So if you are dependent upon high-dose testing, which is the way our system works, you will never see the low-dose effects. And what that means is all of the high-dose testing that we've done for decades have been blind to this type of effect.
Why is it that these chemicals can start to show problems at low doses instead of at high doses?
What hormones and these contaminants do is at very low doses, they turn on and off genes. Genes are being turned on and off trillions of times a second throughout your lifetime. And the orchestration of that is absolutely vital to life. If the genes get turned on or off at the wrong time, that's going to lead to a problem. You're going to lack a protein that might be important, for example, in suppressing a tumor or in controlling the growth of your heart. And the body's control system for these genes is designed to function at really, really low levels.
How low are we talking about?
We're talking parts per trillion to parts per billion to low parts per million.
And this is not even in the area where the safety system is designed to look.
The safety system is not designed to look there. It starts at parts per thousand and rarely gets to low parts per million and never gets to parts per billion.
So we've all heard the phrase, the dose is the poison. And that really is the assumption that a lot of toxicology is working on.
It's an assumption that's been around since the 16th century. It was based upon work by a guy named Paracelsus in Switzerland. And the way the tests work today is we think that by testing at high doses, we're going to see everything. So that once we get to a dose that's intermediate and we don't see anything, we're golden. But this science is telling us that at really low doses, as contaminants mimic hormones, they can have effects that are totally unpredictable by what happens at high doses. And now we're watching as toxicology is overturned by new science from endocrinology. Endocrinology is the study of hormones, and it's only because endocrinologists brought their skills and knowledge into this field and began asking these new questions that we began seeing results like this beginning about a dozen years ago.
So it's emerging science, but it's not brand spanking new. Why haven't we been looking for this sort of response when we're trying to determine whether or not a substance is safe?
I should emphasize that it's not even close to brand spanking new. It's solid in endocrinology. This is something that physicians have to structure their drug deliveries around. They know that at low doses you can cause effects that don't happen at high doses. In fact, you can cause the opposite effect. And the best example of that is a compound called tamoxifen that's used by physicians to cure breast cancer. It works at high doses to suppress the growth of the breast cancer tumor. That's exactly what you want it to do. But at a level about 1,000,000-fold beneath that toxic dose, it turns on genes that are responsive to estrogens and causes the breast tumor to grow. And if you only do the classic experiments of high doses until you don't find an effect, you miss this.
And are we beginning to see that that's happening, that the findings from endocrinology are indeed being put to work in our safety system?
Well, not yet. There's a battle underway today over bisphenol A. The low-dose experiments say it's risky and we shouldn't be using it with food products. But to date, the agency reviews of bisphenol A have basically depended upon traditional high-dose experiments by contract laboratories and have not been willing to pay attention to the low-dose studies published by academic scientists doing this new research. Another endocrine-disrupting compound that has been shown to have these different effects at low doses than high doses are some of the phthalates, a common plasticizer added to plastic to make it pliable and soft. There's fascinating work showing that at really low doses, Phthalates alter our responsiveness to allergens. They make us hyperallergic. So the standard tests that are used to assess toxicity don't even begin to tell you about this effect of phthalates. Interestingly, we know that people today are experiencing increasing frequency of allergic diseases like asthma and like allergies. And now we're seeing that one possible mechanism of it could be our exposures to phthalates.
So maybe that gives us some insight into why the bisphenol A issue is so hard fought, that it's about more than just BPA, isn't it?
It is about more than just BPA. BPA itself is a big deal. You do the calculation, and it's worth about $800,000 an hour. You can buy a lot of lawyers to defend your product with $800,000 an hour in revenue. But BPA is the poster child of this low-dose debate. And if BPA is regulated based on low-dose effects, it explicitly acknowledges that the regulatory system has been blind to these types of effects. And BPA is not the only one that's going to have to be re-examined.
Now, EPA has been taking some steps in this direction. Give me an assessment of what the Environmental Protection Agency has been doing in terms of these endocrine disrupting chemicals.
Very little. There was a program that's been underway, mandated by the Food Quality Protection Act of 1996, that instructed the EPA to develop testing and screening criteria for endocrine disrupting compounds. And just this past year, it identified candidates to measure. Congress actually expected them to be measuring these things within a few years, and here we are 13 years after the passage of that act, and EPA has just identified what candidates they should look at. And it's a small, incomplete list.
That's Dr. Pete Myers, CEO and Chief Scientist of the nonprofit Environmental Health Sciences. You can read that paper on endocrine disrupting chemicals at our website, LOE.org.